I'm going to try to give you an overview a little bit about what I think 24-hour movement behavior analysis should look like and where we can go in the future with this. Try to give you a little bit of a flavor of this. And if you like it, you're more than welcome to contact me at any point in time and discuss that any further. So without further ado, but before I'll start, but before I develop the subject, I just want to give you a little bit of background of where I come from. It gives you a little bit of context to the work I do. I live in Glasgow, which is the largest city in Scotland. Scotland is a small country in the north of Europe. There's only about 5 million of us in Scotland, and most people, 1.5 million, live in Glasgow. So it's kind of an ultra-urban city that has a long past, an industrial past. We say that it's actually built on 4 evils, which are sugar, tobacco, opium, and slavery. And what happened in Glasgow is we have a good sense of humor, and we don't take ourselves too seriously. That our past is industrial past is an heritage, but that heritage faded away with the closure of the shipyards, essentially. And Glasgow went through a long period of decay and degeneration, which created a very specific environment, quite unique in Europe. And we are in a position where there is something called the Glasgow Effect. And it's a rather strange thing in a sense that if you look at the longevity of people in Glasgow across all social classes and strata, we tend to die about 10 years earlier than anybody else if you compare like for like. So if you were to compare Glasgow with other European cities with the same level of deprivation and social structures, we still die a bit younger, and we don't really understand fully why that is the case. It's called the riddle of the Clyde generally because it's an unknown quantity. But there are some important statistics about Glasgow. We say it's the segment of Europe because it's the worst city in the worst country in Europe for just about every health indicator. So we have a quarter of the population has multiple chronic diseases, a quarter of the population is obese, and we have a quarter of the population that lives below the European poverty level, and that is 1 child in 3. What is remarkable is the change in industry in the town, which at the age of the shipyards, people worked physically incredibly hard and they struggled to eat enough food to sustain themselves, burning over 3,000 calories a day, to being mostly a service industry, mostly call centers where people are sitting all day. So there's been a dramatic change in the people's daily use of time, daily pattern of activity. And that's really what drives my research. But most people are interested in physical activity, which is quite a complicated and complex, very much like the nutrition conundrum. Is quite complicated. But we decided to go one step further. Let's go and look at a whole day rather than just a physical activity. Let's make it a bit more complicated. What would that be the case? Why would we be interested in doing this? That's fundamentally the kind of shift in thinking that I kind of came across while studying physical activity. So the 24-hour day, why should we consider it? Can we measure it? How can we analyze it? What are the potential caveats? And where is the future? So it's kind of some topics I want to touch on today with you. Why? Very precisely is because it's challenging our thinking. It will actually allow us to understand physical activity behavior probably better, because physical activity behavior interacts with other behavior we do during the day. And it will also unite the fields with other colleagues that work on sedentary behavior or on sleep, or even on nutrition or on the outdoors, all these kind of things. It just creates a more kind of unified field in my mind. And finally is the problem of accuracy, which I'll touch upon. If we are trying to understand the relationship between physical activity and some health outcomes, or even the determinants of physical activity, if we don't take into account the interaction between time we spend in physical activity and other behaviors we do, then we are probably not being as accurate and as objective as we should be. So my work is what I call behavior dynamic. In every day, we have a narrative of our day. We go and do a number of activities, and we choose to do some of them, or we are forced to do some of them through the day, and that makes essentially a sequence in time of these activities. What I'm interested in is the dynamics of it. How do we go from one activity to the next? What are the choices we have? How these choices determined or forced by external forces, which can be our environment, our policies around us. And at the end of the day, how much of each of these activities do we do? How does that influence our health? And how can we change that potential? So that's where essentially in the year 2010, that we started having conversation with other colleagues around the world, thinking only about physical activity, or thinking only about sedentary behavior, or thinking only about sleep in isolation was not really a fruitful way to go, because he brought a lot of conundrum to us. And I'm just quoting here a paper by a dear colleague, Matt Goodman, who basically realized that 24 hours in a day, it's a closed thing. We can't have 25 hours in a day. So we can't extend physical activity forever, or sedentary time forever, or sleep forever. We are bound by these 24 hours, which means that every time we engage in one of these behavior, we necessarily have to not engage in another, which meant that these behaviors are essentially codependent. Yet most of the time when we looked at them as independent variable, or as isolated phenomena. So the difficulty now is to go from this very well established way of thinking that is, let's look at thinking isolation, to actually let's try to think about all these things together. And we had a talk earlier on about the complexity in nutrition, and that's a little bit the same problem, because we now have to think of multiple variables at the same time and trying to deal with this added complexity. But there is a way forward, both in terms of concept and in terms of the supporting mathematics behind that, and the statistics that help us navigate through this. So, but before we go there, there's a fundamental for me of human behavior dynamics. And I fundamentally think that as a human, I am stuck every day in this conundrum, which is that I am made to move. We are incredibly efficient as a machine for movement. We can not outrun a cheetah, but we can, because we sweat, we can run longer. The cheetah will have to stop because his physiology, his temperature will go up, the physiology will stop working, and it will have to stop. As a human, we can keep going. There's incredible feats that people can do, ultra marathons and all these kind of things. So we have the capacity to move. We are very, very efficient. But I think there is something in our reptilian brain that forces us to conserve energy as much as we can. So, and that is seen in the kind of the pattern of search for energy sources of any hunter-gatherer species. And that's the graph you can see at the bottom. You see, if I'm looking for food or for energy sources, I'm not going to look randomly, constantly, and just move around randomly trying to find something. What I'm going to do is I'm going to try to go to a place where I know there is some, and then I'm going to look around there. And if I run out, or if I don't find anything, then I'm going to make a big investment in energy expenditure, go somewhere else where I think there might be a better chance to find them. That's what we call a levy flight. that's a different pattern you can see at the bottom of the screen, where I'm going to go where I know there is a source of energy, and then I'm going to search around there, and then I will rest as soon as I'm replenished. And that's what we see in the structure of our cities. If you look at the structure of most cities, they're organized in such a way that we can go to a supermarket and we know that we're going to get everything we want. We jump in our cars, we go home, and we sit in front of the telly. And that leads to objectively what we see in the patterns of daily physical activity. And that's the graph you see at the top, is that as humans, we don't accumulate physical activity in long bouts. We tend to do things in really, really short bouts. And actually, objectively, when we are looking into accelerometry time series, what we see is that most of the bouts are 1 or 2 minutes long. And then there will be a rest in between. And these rests can be very short for most, but they can be incredibly long, which means I would have in my pattern very few long bouts of sitting or resting, but these contribute a great amount to do the total amount of time I'm spending sitting. While physical activity, on the other end, is accumulated in really short bouts. And that's a pretty universal pattern we see in just about every traces of accelerometry I looked at. And it's explainable by this hunter-gatherer kind of pattern of behavior. So it's something quite difficult to shift. And if we look now at the general pattern of activity of our time use over the last several decades, there's been a dramatic shift in the way we spend our day. So if I go from left to right, in the 1960s, you can see there was a great deal of energy expenditure, and on the right-hand side is gone down overall, and is predicted to go further down. But what's interesting is the top band is actually sports. And in sports, that has not really changed. If anything, that proportion of our energy expenditure in engagement in sports, although it's not true for everybody, but as a population, at least in the UK, and this is true in many developed countries, that proportion in sports is actually increasing a little bit. So we are kind of winning on that front, but most of our energy expenditure decline has come from somewhere else. It's come from our occupational time and from our other leisure time and commute time. And that has been replaced by this black line, which is the amount of time we spend sitting. So we see a dramatic shift in the composition of our activity in the day, both in terms of the time and in terms of the energy expenditure that we do every day. So, and that's really important, because this shift in activity is actually something we see also in terms of interventions. So there's 2 examples here of studies that have been in Australia, where when you have a really nice intervention that promotes physical activity and you engage people in it, they will increase the physical activity. But as soon as you remove that intervention, the behavior will go back to what it was, or even worse. In the case of the paper on the right by Nikki Ridges, actually people will tend to compensate. So if I take kids at school and I make them do more sports, they'll spend more time sitting at home when they get home in the evening. So we might be winning on one side of the composition, but then losing on another side. So that's the reason why for me, it's really important to see the day in its entirety, rather than just concentrating on one part of it, which is the physical activity or even the sports side of things. So I want to have like this integrated view of the whole day so that I can understand all these interactions. And that was really interesting if you were in a physical activity research world in the year 2010 around this, because that's at a time where research on sedentary time or sitting time became really prominent, and a lot of researchers were showing that there were association between the amount of time we spend sitting and all sorts of health outcomes, including mortality risk and many others. But the physical activity researchers were saying, well, actually, that's not quite true, because people might be physically active the rest of the time. So that might compensate for that. And we had this incredible debate that went on forever. And in 2016, that came to a crunch, because there were two major meta-analyses done on all the research we knew at the time, and they came to dramatically opposite conclusions. So at the top, there was a meta-analysis by Biswas that showed that the effect of sedentary time was independent of physical activity. So in other words, it doesn't matter if you did some physical activity. If you're sitting, that's still gonna have a detrimental effect on your health. And then at the bottom, you had a paper by Wolf Ekelen in the Lancet, which was a landmark paper that should actually, if you engage in physical activity, it completely attenuates the effect of sitting too much. So these two major papers were dramatically opposite. And for me, that was distinctive to a moment in time in science where there is such a clash of thinking that is not possible to reconcile, that we needed something different, or we needed to think differently about the problems. Because essentially, are the effect of sedentary times and physical activity independent? And the answer was both yes and no. So as a physicist, for me, that was a little bit like the Schrödinger cat conundrum, where you have a cat in a box and you wonder if the cat is dead or alive. So to find that out, you would have to open the box. But if you open the box, there is a mechanism that would kill the cat. So you would never know if the cat was alive or dead. So we needed something to think slightly differently. So that's where I started questioning the way we conceptualize physical activity. So if we conceptualize physical activity as both out there as being just a two-state problem, I'm either active or I'm resting or I'm inactive, then you can consider these two things to be slightly independent. Because if you look at one, then you also that the other one is the complete opposite. It's the other side of the coin. So if you have only two states, that's fine, that works. But as soon as you start thinking about other states, so you might break the physical activity into moderate to vigorous physical activity, light activity, or that could be indoor activity, outdoor activity, leisure time activity, occupational activity. If you start chopping this into smaller subcategories, then there's a transfer of time that happened between those, and then it can't become independent anymore. Therefore, they are all codependent. And I'm going back to a statement from Matt Bierman. If you're engaging in one, then you cannot engage in the other. Therefore, if you increase the time in one, you have to decrease the time somewhere else, because there's only 24 hours. And that's what led me to do this simple demonstration. Imagine I have these two states. So I'm either active or I'm inactive. And I'm in the first point on the left. I spend 7 hours of my day being active and 16 hours being inactive. Okay. And now I'm engaging in an intervention that will suddenly increase my active time by 2 hours. So now I am active for 9 hours. But now what happened is I have increased my total day to 25 hours. So I've invented an extra hour because I've only looked at the active time and I forgot to subtract that from the inactive time. So there was something in our thinking as physical activity researchers that wasn't quite right. So I wanted to fix this. And the idea here is this idea of composition. We have a whole day and everything we do in that is a part of it. And the sum of that part makes the whole day. Therefore, everything is relative rather than absolute quantities. So I have to think about everything with respect to the other part. And then I had a mathematical problem, but fortunately, I'll tell you about it later. Somebody solved that many, many years ago. But now we are in a different, we have to think differently. We have to think about our day as a cocktail, essentially. So you have other similar problems. So you can think about a dish, to go back to the nutrition thing, and our dish is made of carbohydrate, protein, or fats. You can think about a medical pill that the doctor might give you. It will be made of a filler, some lubricant, some glidant so that you can swallow this. Then there's some binding agent to make sure that thing doesn't fall apart. And there might be one or two or three potent drugs within that has an effect on our health. And there is our daily activity, which can be split into sleep, light activity, sitting time, sports, whatever you want. But they all constitute a whole. If I look at a dish, if I want to change somebody's diet, I can do two things. I can reduce their portion size, so I can give them a smaller plate or a bigger plate with the same composition, so the same amount of carbs, proteins, or fats in it. Or I can give them the same size of plate, but change the proportion inside of the ingredients. So more or less carbohydrate, protein, just to balance the diet differently. So I have two modes of action. Similarly, if I have a headache and I'm taking one pill and it doesn't go away, I can take 3 pills. So I can have more of the same drugs. Or I can go back to see the doctor and say, well, give me something stronger where the proportions of the active ingredients will be larger. But when it comes down to physical activity and our daily activity, we're stuck. And the only thing we can do is change the proportion of the day, because we can't increase the size of the day. So we have to think about how we change the whole structure, the whole dynamics of the day, the whole proportion of the day. So the cocktail. And since then, I've been on a chase with many colleagues like Dr. Dumit and Borja, just to try to understand how is this cocktail put together, how can we modify it, and what is its impact on health. So interestingly, thinking about this, we can reinterpret some of the results that have been published before, because we have to be consistent with what has been done before. Otherwise, we would be breaking the whole field. But taking Ulf Ekelund's results, and I've had this discussion with Ulf several times, where I told him, well, you kind of misinterpret your own result a little bit, because I can look at them in a different way. So what you're seeing here is a dose response of mortality, so the hazard of early mortality or premature mortality against different levels of physical activity. But you have 4 different curves because they correspond to 4 different levels of sitting. And fair enough, if you are doing a lot of physical activity, which is on the left-hand side of the curve, so more than 35.5 METs per week, which is about 2 hours a day of MVPA, which is a lot for most people, well, there's no effect of sitting whatsoever. But on the other side, if you're doing very little activity, you can see that the curve goes up if you're sitting more and more. So if you're sitting more than 8 hours a day, your risk is much higher than if you're sitting for 4 hours. But what's more interesting is for example, these 2 points. In these 2 points, they have exactly the same level of risk, but they are completely different combinations of physical activity levels and sedentary time. Similarly, you find that here. So that means there is potentially more than one way to get to Rome. That means I can bring people to the same level of risk reduction or risk increase for any health outcomes by manipulating different parts of the composition together. And that is really interesting because that means we suddenly have much more levers for action in terms of public health and developing messages or interventions that would make people healthier or live happier and lives with better well-being. So
let's look back about our guidelines, because our guidelines actually, and I was really pleased to work with Vicky on the latest World Health Organization guidelines. But actually, the guidelines themselves had the wording of the guidelines had the key to this conundrum, because they ask us to do 30 minutes per day or 150 minutes of MVPA per week. And you can see immediately, if you look at the unit, that it's time over time. So it's not an absolute quantity. The guidelines are actually asking us to change a proportion. They're asking us to change the percentage of time we spend of our day doing certain things. So everything for me was totally consistent with this idea of the day being a composition. So that means essentially we have this idea that we have to consider physical activity or sedentary time or sleep time as a relative quantity to the other ones, because otherwise even the fathers of statistics tell us that whatever correlation we make, if we think about it as an isolated quantity, is actually spurious. So a lot of the numbers we're crunching might be actually rather inaccurate. So the solution came from compositional data analysis, which is actually something that was solved in the 1980s by a brilliant Scottish statistician called John Hutchinson. And he thought about, okay, on the left-hand side here, you have the typical way we think about quantities, which are independent. So they are orthogonal in space. They have different, if you move along one axis, you're not changing the other axis, which is exactly the time machine I showed you earlier on, to thinking in terms of this triangle, or which is called a simplex mathematics, but it's basically a space in which when I change one of the quantities, automatically, if I go from point A to point B, I will have to change the other quantities, which made it really simple for us to then rewrite some of the statistics in very simple ways to actually being able to compute everything and estimate everything from the point of view of a proportion and a composition. So essentially, you have to think about anything you do, rather than putting one quantity in it, you're putting a pie chart. Now, you've all done compositional data analysis when you've written a pie chart. Pie chart is the basis of a visualization of a composition. So you're making models, you're making, you're interpreting the result of an RCT, but instead of having one quantity, you're putting a pie chart into your equations or your model. And that can be done through very complicated equations, but actually when it comes down to it, it's very simple. All we have to do is take the quantities of the day, so my sedentary time, my light activity, my MVPA, my sleep, and do a simple transformation, which looks mathematically quite complicated, but when it comes to it, it's actually quite simple. So we can transfer everything we know without having to change anything into this new space that John Hutchinson developed. So it's relatively easy to do, and all you have to do is to think in terms of proportion. So when I have a model or a statistical test I have to do, instead of putting one quantity, I'm going to put a combination of them. And they're called ILRs, or isometric log ratios, but they are constructed in a really clever way. So let's take the first line, and I can construct them in such a way that I can see whatever contrast I'm interested in my data. So for example, on the first line, the first ILR, the first coordinate that I'm going to look at is sleep plus sitting time ratio over my standing time and my physical activity time, or my light activity and MVPA. And that tells me the ratio of time spent in being inactive to the ratio of time being active. And I can put that in my model and I have that immediately as an answer. Or I can look, but they have to be consistent. So I can create whichever contrast I want, but the important thing is to think in these terms, in terms of balance of time between different behaviors. And we have pretty useful guide to do that, that are available on Plus at the moment to do this. And you can transform them in any way, shape, or form you want to suit the needs of your study. And so doing that, we took Ulf's data and we reprocessed them in a compositional way. So if you remember, I showed you these two boxes. So we took this data and we put them into H-instance triangle. And we thought, what if we reinterpret this data, not in terms of two independent variables, but as a ratio of the time spent active and the time spent sitting or sedentary. And fair enough, we found the dose response curve you see at the bottom, which is exactly the same result as Wolf's result, but it's expressed as a single curve rather than 4 curves. And it contains all the same information, but it takes into account that codependence. And you can see that we can immediately interpret this as, well, I have a risk level for a ratio of time between moderate to vigorous physical activity and sitting. And we interpreted that as being, so if you want a 20% or 30% increase, that is equivalent, that's the circle in blue, that's equivalent to 1 minute of MVPA for every 20 minutes of sitting, or 3 minutes of MVPA for every hours of sitting in the day. And that gives you exactly what the guidelines have been trying to do up to now. So that gives us multiple strategies to move people along that curve, dose response curve, because we can have different strategies. We can try to move people from light activity to more moderate to vigorous activity, keeping their sedentary behavior the same. And that would be very much the case in somebody that works in an office, and I cannot go out that has only a set amount of time. So let's increase the intensity of the exercise they do, and now we'll shift them up on those response curve. Or we can try to change some of the sedentary time as well. So that's a second combined type of intervention we can do. Or for maybe some people have so little time, or that are basically so busy standing on their feet all day like a nurse in an hospital, what we can try to do is shift their sitting time to light activity time. And that means that ratio of MVPA to sedentary behavior is going to go up. And that means their health is going to improve. So that gives us multiple ways of strategies for interventions in the future. And that's what we tried to do recently. So last year, we published a paper where we brought 6 different cohorts of objectively measured composition of the 24-hour day. And I think it sums up to about 150,000 people that were acceleromically 7 days. And we combined this data and we produced this heat map that shows the mortality risk or hazard ratio on this ratio of MVPA to sedentary time. And so you can see the green area is like, area where people have a lesser risk of mortality. Blue area is, red area is higher. But again, you can see that there are 3 compositions presented here, 1, 2, and 3, that have different amount of sedentary time and MVPA and light activity, which is represented by these diagonal bars, that actually have the same associated risk. So we can really indeed use multiple levers. So that I think there is enough empirical evidence there to see that that is the case. So the solution is not just to push sports. The solution is that we have to transform many other aspects of our daily activity to be able to do that. And again, so more than one way to get to Rome. And it's exactly the message of most current guidelines, which is every move counts. Every time we shift a little bit to a higher intensity of activity, we are actually making gains. And we see that replicated in Canadian guidelines that were completely, and I think in Australia in some parts as well, completely adopted this idea of 24-hour movement guidelines now. So striking the right balance, you can see there, again, from the same data I showed you, a clear dose response between the ratio of moderate to vigorous physical activity to mortality risk. And we calculated that to get the kind of risk reduction that is demanded in the guidelines is around 3 to 4 minutes of MVPA for every hours of sitting you do in a day. And that equates to about 27 minutes per day. So it's not very far off the guidelines. But again, it's a relative thing. So we think that this is quite a nice little message to give to the public, because most of our day is actually contingent to the amount of time we spend sitting. We have little choice over that at work and in places. So I would recall the amount of time I'm spent sitting a bit more easily than the amount of time I spend active. So I can just look at my normal day and say, well, today I'm going to be in the office for 10 hours. So 10 hours of sitting, I'm going to have to go out and spend, 27 minutes being really, really active throughout that day to compensate for that. So that gives a clear, simple message that combines all the activities of the day into a single sentence. So now, can we measure physical activity or 24-hour? I prefer the term physical behavior to movement behavior, but can we measure it? Yeah, absolutely, we can. Throughout our day, we can measure it with multiple sensors, or even through recall diaries. We can think about it into a two-state, active or inactive. We can think about it, if we add a GPS to that, as in being indoor and outdoor, and active and inactive. We can then develop postural things, multiple sensors that allow us to have a much, much more detailed composition of the day. And I think that's where the future is that we can actually look into this composition in more detail. So the moment most studies have a composition of the day that is in 3 to 5 parts, depending on what it is, but with new sensors that we have, we can actually tweak this to have multiple subcategories and see which one of these are maybe more potent in terms of improving our health, or actually more malleable in terms of behavior. So you can see there's hundreds and hundreds and hundreds of new devices that are commercial, that are coming onto the market. They tend not to stay for very long. The big brands are staying, but there is a very short lifespan for most of these new technologies. They tend to emerge quickly and disappear when there is not enough of a market share for them. So we've had some really poor outcomes in that respect, where we invested money in buying some of these devices that are then disappearing. So for your research, I would advise you to be a little bit careful with this. And obviously, as I said, we are made to conserve energy. So that's a new device I found on the internet that actually allows you to increase your step count and your MVPA by putting your phone into a cradle that moves it for you, so that your statistics will go up, which might be interesting in the sense that there is a slight ethical danger that is reappearing of insurance companies linking these sensors to your insurance plan, and if you're not active enough, they'll just increase your premium or decrease. So let's keep an eye on this ethical part of things. So there are some really good commercial devices, and they're improving research grade devices. They're improving the way they are classifying the activities with more accuracy. So one I've worked a lot with was HPALS. We started with 3 possible states: sitting, standing, or walking. And now they've expanded that to be able to recognize different types of ambulatory activities, so walking or running. some cycling, and even whether you're lying rather than sitting. So there's a really great improvement on this. I see a lot of benefits in using this in combination with cameras, and machine learning will come out of this, giving us more states. There was some fantastic work done at Oxford by some colleagues there. And there are also other techniques, not compositional techniques, but I look at pattern a lot more, that are very interesting, such as functional data analysis, or looking at pattern search, almost like a barcode of your day, to see how you're going from one state to another, or even putting the whole waveform into some, the acceleratory waveform into some form of analysis, which is essentially compositional in itself. There's some caveats to that. Compositional analysis is not a panacea. There are still many other problems to solve. And one of the biggest one is, how do we actually cut the slice of the day? I'm willing at the moment for a massive expansion on the number of subcategories so we can understand what's happening more. But how we label and how we conceptualize these categories is important. And at the moment, there are about 20 different ways of cutting the day that are through some form of consensus. So you can see that I can take the 24-hour day and I can conceptualize it in multiple different parts and combinations. And it's good for exploration, but at some point, we're going to have to agree on some sort of naming and categorizing all these things, because we'll have to put our ducks in order to have more consistent research. And that's the reason why we've set up the Alphabet project with many colleagues, try to have an open science consensus over how do we name all the activities in a day so that we can share and harmonize the research. And there is the problem of sleep. We only consider it as a time quantity, but actually in most research I've seen, the time you spend sleeping doesn't have much association with health, but there are other characteristics to sleep, such as the quality and things like that, that are not captured by compositional data analysis. That might be really important. And that's all I have to say. It's a bit of a whirlwind tour, but I'm quite happy to take questions. And as I said, you're very welcome to get in touch. Most of our codes and material is on our website, Open Coda. It sometimes goes down because we don't have funding for it. So, we keep it up as we can, weekends and evenings type of situation. So I apologize if it's down. Thank you very much.